Dear students, greetings from Dr. T. Sendil Murugan, Associate Professor and Head, Department of Information Technology, Kakatiya Institute of Technology and Science, Warangal. In this video lecture, we are going to discuss about recursion concept. It is one of the application of stacks. So already we discussed about what is stack operations, how to implement the stack, how to implement the multiple stack. Those things we are discussed in the previous videos. In these videos, applications of stack, where the stack concepts are used that we are going to discuss in this video. The first concept is recursion function. When we are doing the recursive functions, how the stack is used to perform those operations, that we will discuss in this video. So dear students, this is week 4 lecture 3 classroom discussion topic 12 CDT-12. We are going to discuss about applications of stack. One of the application is recursion. So in this video lecture, specifically we are going to discuss about recursion concept. So after completion of this lecture, students will be able to develop a C program to perform a regression operation using stack for multiple applications. So we are going to discuss about what is regression, how the regression is working using stack concept, and if you are discussed those concepts, you have the capability to write this program for real-time applications. So these are the applications of stack: reversing a list, parenthesis checker, conversion of an infix expression into postfix expression, evaluation of a postfix expression, conversion of infix expression to prefix expression, and evaluation of prefix expression, regression, tower of Hanoi. So these are the applications of stacks. So individual topics are individual applications. Okay. So now we are going to discuss about recursion concept. From the last second one, recursion is the one of the application of stack that we are going to discuss this video lecture. What is recursion? A recursive function is defined as a function that calls itself to solve a smaller version of its task until a final call is made, which does not require a call to itself. So what is the meaning? Actually, recursive function means if the function is there, okay, so this function is there, this function will call itself, function call itself till satisfy some conditions. Okay, so here we will give some condition. Up to satisfying this condition, this function will call itself. This is recursive function. So when we are writing the recursive function, we have to consider two major cases. One is base case, another one is recursive case. Okay, base case means when the calling will be stopped. Okay, so we are calling continuously, where it will be stopped. That is the base condition. So which problem is simple enough to be solved directly without making any further calls to the same function. So without calling again, it will be over. So example, factorial of 1 equal to 1, we know that. Okay. So whenever we are calling with one value, no need to call the function. Directly we can assign the value. Okay. So example I'm set. The second one is a recursive case. What is a recursive case? In which first the problem at hand is divided into simpler subparts. The small part we have to consider. Then second, the function call itself, but with subparts of the problem obtained in the first step. Okay, 3 steps is there in the recursive case. First one is problem will be divided into small subparts. Second one is function call itself, but with the subparts of the problem obtained in the first step. Second part is function call. Whenever we want, we have to call the same function. Third one, the result is obtained by the combining the solution of simpler subparts. Okay. So how many times individually it will be executed? If example factorial 5. Factorial 5 we have to calculate. Factorial 4 we have to calculate. Factorial 3 we have to calculate. 2 we have to calculate. Factorial 1 only we know. If you want to calculate factorial 5, first we will take factorial 5. What is factorial 5? Factorial 5 into 4 factorial. Like that it will go. Factorial 5, factorial 4, factorial, like that. When it will be come back, it's a reverse order. Okay. Factorial 1 equal to 1. 1 into factorial 2. Okay. So what is the 2 value? Like that it will be executed with small parts again and again. That is recursive case. Here example I told you, we will take the factorial 5. How we can calculate the factorial? So if example 5 factorial means we know that 5 into 4 into 3 into 2 into 1. Okay. So this is we know that. So what is the value actually? Value is 120. So how we can calculate normally? If 5 factorial means 5 we will start now. So remainings are 4 factorial. So how we can write? 5 into 4 factorial. 5 into 4 factorial. What is the 4 factorial? 4 factorial equal to 4 into 3 factorial. Okay, so how we can write it? Rewrite it. For 5 factorial 5. For 4 factorial 4 into 3 factorial. Okay. These 4 again 3 factorial. What is the 3 factorial? How we can write the 3 factorial? 3 into 2 factorial. How we can write the 2 factorial? 2 into 1 factorial. So we know that 1 factorial is 1. So like that we can calculate. Finally 1 factorial is 1. So when we are combining these things, it will be multiply 1 into 2, 2 into 3, 3 into 4, 4 into 5. Like that will multiply. Finally it will show 120. Okay. So now in this factorial function, base case is n equal to 1. Whenever we are given 1 factorial, the value is 1. That is the base case. What is the recursive case? Recursive case means n into factorial of n minus 1. Again and again this part will be called till reach the base condition. That is recursive case. Okay. So example diagrammatic representation. 4 factorial. How we can calculate the 4 factorial? For example, factorial 4 factorial means 2 into 4 into factorial 3. If 4 means we know that factorial of 4. Okay, 4 into factorial of 3. So how we can calculate 4 into factorial of 3 is 4 into 3 into 2 into 1, like that. So how it will be there? Again, factorial 3 means 3 into factorial of 2. Okay, 2 factorial means 2 into factorial of 1. Whenever it is comes base case, factorial of 1 equal to 1. So what happened? This 1 will goes to here. Okay, 2 into 1. So again, 2 into 1 is there, no? This is for factorial 2. So 2 into 1 will goes there. 3 into 2 into 1. Okay. So this 3 to 1 is factorial 3. So instead of factorial 3, it will go like this. Okay. Finally, we can calculate 4 into 3 into 2 into 1. Okay. When we are comparing with the stack, how it will be working, that you must be know. Okay. So initially, factorial 4. We are push operation factorial 4. So again, factorial 3. So 4 into 3 factorial. Okay. So next 2 factorial. Next 1 factorial. So now we know that value, factorial of 1 value. What is the factorial of 1 value? 1. Okay. So if you know that factorial 1 value is 1, base conditions, then it will shift here. Okay. That 1 value. So factorial 1 over. 1 into factorial of 2. What is the factorial 2 value? 2 into factorial of 1. Okay. So again 2. It is 2. What is that? Factorial 2 equal to 2. Next it will come here. Okay. So 2 will comes here in 3. 3 into 2 factorial. Factorial 2 value is 2 already. What is the factorial 3 value? 3 into 2. So 6. Okay. So 6 will be stored there. Then next 4. Factorial 4. What is the factorial 4 value? 3 factorial value is 6. Here 4 factorial. 4 into 6 24. So finally 24 will be stored here. Okay. Now we can understand what are the parameters which are to be stored in the stack when a function call is called. So what happened normally? So when we are writing the C program, we can write function, then from the main function example, from the main function we are calling that function. Okay. So after calling this function call will comes here. Okay. So in case this function call have own recursive function, what happen? So it will store temporarily this value, then sub program it will be called. So example, factorial of 5 is there. Factorial of 5 equal to factorial of 5 minus 1, factorial of 4, factorial 4. Then again, this when we are calling this function, where the values are stored temporarily. Okay, that is the first value. Current values of formal parameters where we are stored. Second one, values of the local variable, formal variable and local variables. Finally, what value it is written for after executing the particular call. So all three are considered as activation record. Okay, current values of the formal parameters, that means value passed to the function arguments. Value of the local variables which we are stored in the local variables, and return addresses. After executing, what address it will be stored. So that is the return address. All 3 points are considered as the activation record. Okay. So for example, same function 3 times we want to execute. Okay. So for example, factorial 3. So you consider like that. So how we can write factorial 3 means 3 into 2 factorial. So first time this is the function call, this is the function call, this is the actual value, and then this function call is there, no, where it will be written. So second function 2 factorial. So again this is the, so example, first function alpha, function beta, function gamma. Okay, the gamma, how it will be work, that means this is the first value, after the second 2 factorial, for this again 2 3. So what are the things are there? Local variable, return address, argument of the function. These three will be the activation record. Okay. So each time 3 times if it is called means 3 times it will be stored. Okay. So for this purpose we need the stack. For example, we know that the recursive function to find the factorial. So initially we will get the number, we will call the function with number value. After executing, this will be written here. Okay, that's the return address. So how the function will work initially? Initial condition n equal to 1 means return 1. So what is the initial condition? N equal to 1 means return 1. So answer is 1. So what happened? N equal to 1. Fact of n minus 1. So if n equal to 5 means 4. So 5 into 4 factorial. For this again call the function. 4 factorial means 4 into 3 factorial. Like that it will execute. Already we explained. Okay. Finally, if we are given n value is 5 means it will calculate it 120, it will print. How it is working? Initially you see here, first factorial 5 it will be there. So factorial 5 means again factorial 5 into 4 factorial. Okay. So next 4 factorial means 4 into 3 factorial. And 3 factorial means 3 into 2 factorials. 2 factorial means 2 into factorial 1 condition. So how it is working? Factorial 1 is 1, then this one will goes to here, 1 into 2 is 2, then 2 into 3 is 3 into 2 into 1, again it is 4 into 3 into 2 and 1, like that it will be there. So how it will be stored? Initially, if x equal to 1 means, then initial value is 1, it is popped out. So 1 into 2. So how it will be stored? So this side, 2 into 1. So this will be popped out. So because this value is 2, we know that. Next, fact 3. So 3 into 2. So fact 3 will be popped out. Next, 4. 4 into 3 factorial. 4 will be popped out. Finally, 5 will be popped out. It will show the answer. This is the stack operation using recursive function. So recursive function, what we need? Activation record. So what is activation record? Function call, arguments, return address. Okay. So now we are in the end of the video lecture. So it is a reflections part 1. Using recursion technique is reducing the memory space. It is true or false? So whenever we are writing the program, we are using recursive function means it will increase the memory space or decrease the memory space. This is the question. Okay, so what they are saying, it is reducing the memory space they are given. It is true or not? They are asked. I will give 10 seconds time. You can answer. If your answer is correct, we will proceed further. Otherwise, go back and watch the video. Okay, then you will understand what is the answer. Okay, so your 10-second time will be over within 4 seconds, 3 seconds, 2 seconds, 1 second. So time is over. Now check with the correct answer. What is the correct answer? False. Why? Because it will activation record. No, each value it will be stored. It's need more memory space for storing temporary values. Okay. So it's a summary. We know we are discussed about applications of stack. What are the applications are there? We are discussed. Then definition of recursion, like base condition, recursive condition, how it is working. That those things we are discussed. Example of recursion like a factorial function with diagrammatic representation we are explained. Finally, with the programs also we seen how the recursive function is working. I hope you understood this topic. I think you are enjoying this video. After learning this, you just solve this problem. Develop a C program to demonstrate the use of recursion using stack. For that, you have to find the Fibonacci series using recursive functions. Okay, to try to write the program further. We will discuss in the classroom. So now we are revisit the lecture outcome. Having completed the discussion on application of stacks in recursion function, now students should be able to develop a C program to perform recursion operation using stack for multiple applications. So now you know what is recursive function, how the recursive function is working, what are the things we need to use the recursive function, everything you know. So based on those knowledge, you can apply this concept into real-time applications. Okay. So even if you have doubt, you can refer our reference book, Rima Dareja, chapter number 7.7.4, topic name is regression. Okay. So I hope you enjoyed this video. Any doubt will come, we will discuss in the classroom discussion topic. Thank you very much.